Hello, this is Mr. Win, and this video is over the binomial expansion theorem. And for this lesson, you do want to use a calculator. So first, remember that a binomial is just a polynomial with two terms. This lesson will show you how to quickly raise a binomial to a whole number power. Here's 6 examples. The first one is x plus y all raised to 0. Anything raised to 0 power is 1. Then you have x plus y all to the first power. This is 1 of itself, so this is x plus y. You have x plus y all squared. Well, that's just write it twice. You FOIL it in combined terms. You get x squared plus 2xy plus y squared. You have x plus y altogether cubed. You could FOIL it, combine terms, then multiply, then combine terms again. You get that. You could also use the sum and difference of cubes formula. Then we have x plus y to the 4th power, x plus y to the 5th power. Now it looks nice and clean right here on the screen, but remember how much work it is to do each. Here's the last one, the x plus y to the 5th power, all worked out. If done the normal way, it'll take a lot of time and space. So I kind of color code it. So the first one I wrote 5 times, then I distribute this x to both of these. I distribute the y to both of these. I got 4 terms, I combined them. Then after I combined them, I did again. I distributed the first, because I'm long FOIL, this x squared into both of these. Then this positive 2xy into both of these. And this positive y squared into both of these, to get 6 terms, and then I combined, and then I just kept repeating the process, and you should be able to watch it and figure out if you can pause it, but it takes forever, and you don't want to do this for problems this long. And it could look worse too. So what if I asked you to do x plus y to the 7th power? Would you write it 7 times, FOIL, combine, multiply, and just keep doing it? It's going to be really long. Or even if I had numbers inside, 2x minus 3 all to the 7th power, it'd take forever. So let's find the shortcut. Here's the same 6 from before. Notice some big observations. The first one in red says in each expansion there are n plus 1 terms, where n is the exponent. So the first one has a exponent of 0. 0 plus 1 is 1. There's 1 term. The second one has a degree or exponent of 1. Add plus 1. 1 plus 1 is 2. There are 2 terms. Then we have a square power, so degree 2. 2 plus 1 is 3. There's 3 terms. It's kind of like when we did synthetic division or long division. I always said there's always one more term than the degree. All right, even down here, this 5th power, degree is 5. There are 6 terms. 5 plus 1 is 1, 2, 3, 4, 5, 6. All right, next, in each expansion, x and y have symmetric roles. The powers of x decrease by 1 in successive terms, while the powers of y increase by 1. So let's go to x plus y to the 4th power. Notice here, this is really x to the 4, y to the 0. Then here, this is x to the 3, y to the 1. Then here's x2, y2. Then here's x1, y3. Then here's x0, y4. Now, anything to 0 power is 1. We just don't write that. But notice that each term, exponents are decreasing by 1, while y exponents are increasing by 1. Then the third observation is the sum of the powers in each term is n, matches the degree. So degree here is 4. Remember, when you have multiple variables, the degree is the exponents of each variable added together. So this is 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. 0 plus 4 is 4. All right, and then last, the coefficients increase and then decrease in a symmetric pattern. So that's what this area is over here. All right, so notice the first term just has a single 1. So there's a single 1. The next term has 2 terms, but they both have a leading coefficient of 1 and 1. That's why it's 1, 1. Then it goes 1, 2, 1. So 1, 2, 1. It goes 1, 3, 3, 1. So 1, 3, 3, 1. Same for 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1, and so on. All right, that's actually very important. So the coefficients of a binomial expansion are called binomial coefficients. Our job is to find them. They're very important. There are 2 main methods. The first is the binomial theorem, and that generally involves using a calculator. So this first part is what I was talking about. You can do this to the nth power. Notice the first one of the exponent of n, and the exponent will be 0 for y, and then it's just x's will go down, y's will go up. And they show you a formula to find the binomial coefficient. It's a formula from probability, from geometry. Combinatorial. It's a combination formula. All right, that uses factorials, those exclamation signs. We don't use that in here, but if you want to do it by hand, remember that just means every number, that number times itself times the number underneath it by 1, all the way to 1. So that sounds weird. Here, 5 factorial means 5 times 4 times 3 times 2 times 1. All right, if I gave you 7 factorial, that means 7 times 6 times 5 times 4 times 3 times 2 times 1. Just that number times every number underneath it all the way to 1. And then 0 factorial is 1 by default. All right, we also use this other symbol because they might see this NCR, that's N choose R, but we might use these parentheses, which I will be using here. That also means N choose R. All right, so we use N choose R, and I'll do a problem with that in a little bit. But the second and more easier way is Pascal's Triangle. That involves drawing a triangle and following a simple pattern. So I'll do that one first. So if you arrange the coefficients in a triangle pattern of like the previous problems you're doing, you'll get an array. Notice the first and last numbers in each row are 1. So here's 1, then 1, 1, then 1. All right, every other number in each row is found by adding the 2 numbers immediately above it. So to get this 5 right here, they added this 1 plus this 4. To get this 21, they added 6 and 15. All right, they have one right here. To get this 21, they added this 15 and 6. All right, so you get that. And also notice that the second number is the original exponent. All right, so that's going to be very important later. That's how I use it. Anyways, Pascal, notice that these numbers in the triangle are precisely the same numbers that are the coefficients in the binomial expansion. So if you look at this bottom one, notice it goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Right, just like these numbers. All right, they're the same thing. And we call the first row the 0th row because that's the 0th power. Then the first row is underneath that because it's the first power. And then any row that one goes on forever, the nth row has the nth power. All right, and like I said, the second number matches the exponent. So this 7th row means 7th power. If you look at the 7th power right here, it goes 1, then 7, then 21. See, 1, then 7, then 21. All right, so let's talk about how to use it. First, you identify which row you're on. You find this out by the exponent, here's the second number, or the number of terms. It's 1 more terms than the degree. So some people like trying to figure out which row of the triangle has how many terms. So that seems too tedious for me. Second, you write out each binomial coefficient followed by the part of the binomial with the correct power exponent. Remember, the x thing, the first thing, starts the highest and goes down by 1 at a time, while the second part, usually the y thing, starts at 0 and goes up by 1 at a time. And last, you can simplify if needed. So we're going to use Pascal's triangle to expand these two things. So first, a plus b all to the 6th power. So the exponent is 6. I'm going to be on the 6th row where the second number is 6. So right here. Or some people like saying there's 7 terms. Notice there's 7 numbers in this row. 1, 2, 3, 4, 5, 6, 7. All right, first I'm going to write all the spaces, the 7 spaces with the numbers in there. All right, so at the same time I just did that. Now notice I did not do the signs yet. The signs come later. They're a little trickier. But the next part I'm going to do the first part of the binomial, the a part, in parentheses with the correct exponent. So I'm going to do that next. So that's now done. Then I'm going to do the second part of the binomial, the b part, with the correct power. So I'll do that now. And now that's done. So notice that it goes A6, B0, then A5, B1, then A4, B2, A3, B3, A2, B4. But the exponents for each, the degree of each term is 6, like it's supposed to be. So last, you can simplify, you multiply them out. Now, if they had numbers in there and signs, that's where the signs are important. Otherwise, it's going to be a positive number. So this first one's just going to be 1a to the 6th power, positive. This next one's going to be positive 6a to the 5th, b to the 1st. Then we positive 15a to the 4th, b squared. Then 20, positive 20, a cubed, b cubed. Then also positive, because know the signs, 15a squared, b to the 4th. Then positive 6, a to the 1st, b to the 5th. Then positive 1, b to the 6th. And that's the answer. Now that's the easy case, so let's do a real problem. So let me set up the next one. Here we have actual numbers. So first let's figure out which row we're in. We're going to be in row number 4. So let me erase this and go to row number 4. The second number is a 4. That's good. So here's the 4. And if you want, there's 5 terms. Again, I don't think of that, but 1, 2, 3, 4, 5. So I'm going to write the 5 spaces and fill in the first number. All right, then I'm going to do the first part of the binomial, the 2x raised to the correct power in each term. It's going to go down from 4, 3, 2, 1, 0. Now I'm going to do the second part of the binomial, the negative 3y with the correct power in each. It's going to be ascending from 0 to 4. So 0, 1, 2, 3, 4. That negative sign is very important. That'll help us figure out the sign of each term. Now I'm going to simplify all these parentheses and exponents. This should be a simple calculation in your head. So I'm going to do like 2 to the 4th power, which is 16. then x to the fourth power. And remember, when you have a negative to an even power, that's a positive number. When you have a negative to an odd power, that's a negative number. So I'm going to write them underneath now. Now that I found each, let's write the final answers. The first one, 1 times 16 is just 16. That's x to the fourth power. The second one, 4 times 8 times negative 3. That's going to be a negative number. It's going to be negative 96. X to the third, y to the first. Then 6 times 4 times 9, that's positive. That will be 216. X squared, y squared. And 4 times 2 times negative 27, that's negative. That's also 216. Usually it's not the same. Xy cubed. Then 1 times 81, that's going to be positive. 81 y to the fourth power. Alright, so if you did it the long way, you would have a lot of combining. You would have to be very careful with all your signs and exponents and numbers. That would be your final answer. So now that you know how to use Pascal's triangle, when you use the other one, the combinatorics formula. So Pascal's triangle is quite easy to use for lower exponents, but once you actually find a binomial with a large exponent, it becomes unreasonable to draw so many rows and it takes a lot of space. So here's that combination formula combinatorics is used. You can find the binomial coefficient on any row and any term number by using n choose r. N is the original exponent degree, and r is going to be the exponent of the second thing in the binomial, the second part. So notice right here, this 21 is going to be 7 choose 2. The exponent is 7, that's the second number, that's row 7. And really, it's going to go like this. It's going to go like x to the 7th, y to the first 0, then x to the 6th, y to the first, then x to the 5th, y to the second. See where I chose this 2 from? All right, so let's show you that in the calculator. In the calculator, you're going to press math, go left or right to probability, go down to NCR. The left, we're doing 7, C center choose, and R on the right side, 2. It should be 21. There you go. So using this idea, we're going to figure out the 10th row on Pascal's triangle. So that means the exponent's going to be 10. There should be 11 terms. And the first number should be 1, the second number should be 10 because it matches the exponent. There should be 11 terms. So I'm going to do 10 choose 0, 10 choose 1, 10 choose 2, 10 choose 3, 10 choose 4, then 10 choose 5, 10 choose 6, 10 choose 7, 8, 9, 10. And I'll stop there because that's going to be 10 choose 10. That's all 11 terms. All right, notice the notation changed. Here I actually use the wording. Here I use the probability way, and then here's that parentheses notation. All right, so I'm going to type it all in the calculator and see what I get. All right, so notice the first three are going to be 1, 10, 45. So 1, 10, 45. I'm going to do the next three. Notice the next three are 120, 210, 252. Then the next three are 210, 120, 45. That's 10 choose 6, 10 choose 7, 10 choose 8. And then here are the final two. 10 choose 9 is 10, 10 choose 10 is 1. And if you go into over 10 choose 11, that's impossible, it's 0. How about 10 and 1? And you should know this is real because remember, it's to be symmetric. It goes in order 1, 10, 45, 120, 210, then start 252, then start going backwards. 210, 120, 45, 10, 1. All right, so now that we can create any row on Pascal's triangle without having to draw the triangle, let's see how we can use this. This formula is best when asked to find a specific term, not the entire expansion. They might say find the 4th term of this thing, or they might say find the 27th term of this crazy thing with the crazy power. So we just pick one specific thing. We're going to figure out which n choose are we picking for this 4th term. All right, so let me set this up. So you could set up like me, but that's kind of overkill. Really, you should just go on and figure out the 4th term is where the second part, the y thing, has a 3rd power, because when it goes x9, y0, right? That's first term. x8, y1, second term. x7, y squared, third term. And then x6, y3 is the 4th term, because it goes 0, 1, 2, 3, 4, 1, 2, 3. So I need this one right here. So let me actually write this out the correct way, the full way. So we have 9 choose 3 to get the binomial coefficient times 3x all to the 6th power times negative 5 all to the 3rd power. And I'm going to find those. So 9 choose 3 is 84. So it'll be 84 times, I need to take care of this parentheses exponents. 3 to the 6th power using calculator is 729. That'll be x to the 6th power. And then negative 5 cubed, that's going to be a negative 125. I'm going to put all that together. Again, using a calculator, I get negative 765 4500. This is x to the 6th power. So if you had to FOIL that and multiply and combine so many times, you get a humongous number. So this is how you quickly find a specific term using that combinatorics formula. That's it. Thanks for watching. Ask questions class. See you soon. Bye.